Everybody online can hear me fine? Assume that's a yes.
Yep.
All right, and then this was our assignment. Assignment 4, write a function that in Java that takes a string representation of a binary number as a parameter, returns a string representation of the hexadecimal equivalent. All right, so we're going to write this the long way, and then we'll write this the short way. So what we're going to do is, let's open up Eclipse. I'll actually create a new repository for this. So we'll go into this guy, and we'll call this guy CSC250 Fall 2020 Homework 4. And we'll say create repository. All right, and then I'll go into Eclipse. And we'll go ahead and create a new project. CSC 250 Fall 2020 Homework 4. And we're going to put that guy in the folder we just created. Okay. And then I'll hit finish. I'm going to say don't create for the module. And there is our new project. And I'll right click on source and I'll create a new class. We'll call this guy driver. I'll go ahead and practice my hello world program real quick. Public static void main string array args. Play, make sure it runs, and it does. All right, so now I know I have a working program. Okay, so this is something you'll probably want to commit to memory. You should be able to kind of follow those same steps I just did for creating a new repository, creating a thing inside the repository. Go back and let's publish the repository for the first time. I have these changes, so I'm going to commit them. This is init commit, so that commits it to the local repository. Now I want to publish to GitHub, so I'll click publish. Make sure you uncheck the keep this code private box. And then I'll publish the repository. And now it's up on GitHub. All right, so, and I'll push changes once we start making some changes. All right, now we've written functions in here already, right? So we can create some functions, yeah. All right, so what we want to do is we want to write some code that will convert from a base to decimal. Let's start with that piece, all right? Last time we wrote from decimal to a base, and we built up a string in reverse, dividing by 2, dividing by whatever. So we're gonna go ahead and we're gonna say, let's just do the binary one first. We'll keep it simple. So we're gonna have a static int binary to decimal, and this will take in a string, call it bin. So the idea is this will take in a string that looks kind of like that, and it should produce for me, this is 1s, 2s, 4s, 8s, 16s, 32. So that's a 32, that's a 44, 46. Should give me a 46. All right, that's what we want it to ultimately return. All right, so what we need to do is we need to keep track of the place. So we're going to start off with the ones place. And the ones place is related to the far right value, far right bit in my string. So I need to walk my string backwards. right? So if I had the string 1 0 1 1 0, something like that, this guy is in the ones place, the twos, the fours, the eights, the 16s. So I'm going to start at the end of my string, walk towards the beginning of my string, taking the value that's there, and if it's a 0, I could ignore it. If it's a 1, I want to deal with it, right? I'm going to add my place. So I'm going to have a running total. So I'll have an int sum. That's going to be my running total. Just as a reminder here, if I want to convert something like that from binary to decimal, this is a 1 in the ones place plus a 1 in the twos place plus a 0 in the fours place plus a 1 in the eights place. So that's 1 plus 2 plus 8, which is an 11. Make sense? That's the problem we're solving right now, converting from binary to decimal. All right, so we're going to walk our string from the end to the beginning. So the last, so I'll have int I is equal to the last legal bucket in my string is bin.length minus 1. And I'm going to go as long as we are greater than or equal to 0, because we do want to deal with bucket 0. And I'll walk backwards. So I'll go from bucket 4 to bucket 3 to bucket 2 to bucket 1, so on and so forth. All right. Then each time through, I want to ask a question. If bin.charat I, if that guy is equal to a 1. So if I'm currently looking at a 1, that means I need to add my place to my running total. Right? So this guy is a 1. 1 times 1. So 1 times the ones place is a 1. 1 times the twos place is a 2. 1 times the eights place is an 8. So I can just add my place. I don't need to add the, I don't actually need to do the multiplication, because 1 times anything is that anything, right? So if I'm looking at a 1, I'll say sum plus equals place, but only if I'm looking at a 1. If I'm looking at a 0, 0 times anything is 0. So that's not going to change my sum anyways, right? Now, regardless of whether I'm counting the value or not, place will become double what it used to be. So 1's place, 2 times 2 is the 2's place, times 2 is the 4's place, times 2 is the 8's place, so on and so forth. That make sense? And then when all of this is said and done, I'm going to return my sum. So up here, if I have string bin is equal to 1011, and then I say int des is equal to I get my 11. If I put a bunch more stuff in there, I get a bigger number. All right, so this code converts binary to decimal, right? Now, from last class, here's our homework 3. Oh, I deleted, I can go on to GitHub and get it. We'll just write it again. It doesn't take long. We already wrote a function that converts from decimal to hexadecimal, right? That's what I ultimately want to do. I want to get binary to hex. So I'll say static string decimal to hex. This is going to take a decimal number as a parameter. I'm going to have my string answer that I'm going to start off as the empty string. While des is greater than 0, I'm going to do some stuff. I'm going to say answer is equal to des mod 16 concatenated with answer. And then I'll say des divide equals 16. So that's des equals des divided by 16. And that'll whittle it down. Now we do have a problem right now where this number might not be the value that we need it to be, right? Because if I have a 10, I need that to be an A. If I have an 11, I need that to be a B. So we created a string up here called map. It had all the hextets in it. And then we just say map dot char at that bucket. And then ultimately return the answer. So if I want to test that real quick, if I do println driver dot decimal to hex and I give it my 2989 with our known value of BAD, there's our BAD as our answer. So here is a program that takes a binary number and converts it to its hexadecimal equivalent. Does that do the homework assignment? So we already had this function from last class, going decimal to hex. This is the one we wrote today. It goes from binary to decimal. And these guys are pretty domain specific. We ultimately wrote base to our decimal to base last class, which would work for any base, right? But you know, these guys this will accomplish the task. So before I give you a different way of doing it, I'm going to go ahead and push this to GitHub, so you have this version up there. So we'll do homework. We'll call this simple. Well, because technically this is the long way. We'll say homework long solution. Go with that. So I committed it locally. Now we need to remember to push it to origin. That puts it up onto GitHub. So now you have that version up there. Okay. Now we have to remember our trick. So with a binary number, I can split this guy up into buckets of 4. And then say this is a 1. This is a 1, 2, 4, so this is a 5. This is a 5. This is a 7. And this is an F. 1, 5, 5, 7, F. 1, 5, 5, 7, F. So we know that we have this shortcut to go from binary to hexadecimal, which is why hexadecimal is a popular numbering convention in computing, because binary is there right off the bat, and we can move to base 16 and also to base 32 and also to octal. Remember octal, we can represent all of the octets in 3 bits. All right, so what I need to do is I need to break this guy into 4 bucket chunks. And then I can do my, my lookup. Okay. Now, I'm going to work from the right to the left. Okay, because right to the left gives me a, so if you saw how I divided this, originally I had this extra guy over here on the left, just a single bit. I want to make sure he's padded. I'll bump it to some more zeros. So I need to make sure the length of this guy is a divisible by 4. Which means that how many extra zeros do I need to add? The length mod 4, extra zeros. All right, so let's start off with, I'll write a function here. Static pad zeros for hex. This guy will take in a string bin for as an input. And what I'll do is I'll say for int I is equal to 0, I is less than bin dot length mod 4. I plus plus, and we'll say bin is equal to 0 concatenated with bin. And then we'll return bin. This guy is going to return a string. So there is our number padded with the extra zeros on it. But if I didn't have any extra zeros to put on there, if I already have it as a thing that's a multiple of 4, it won't do anything extra to it. So pad 0 for hex, only this loop only goes through the length of the string mod 4 number of times. So if it's short of being a, actually, you know what, this currently, well, it actually does work. It just doesn't work in the way I maybe intended for it to work, because technically bin keeps changing here. So really I need to say int, all the zeros to add is equal to bin dot length mod 4 zeros to add is what I'll do. That way I only get this value once and put on enough zeros. I take the padding off. Otherwise, you see that each time through here, I am changing the value of bin, which then would technically change this, the math for modding it by 4. Okay, so now I've padded it. So I'm guaranteed that I have groupings of 4 bits, right? So now it doesn't matter if I go from the front to the end or I go from the end to the front. Now, so what I want to do is I need to have a function that will take a 4-bit value and turn it into a hextet. So if I have this guy right here, I need to turn that into a hextet. So we're going to say static string for a 4-bit value. Does anybody know what a 4-bit value is called? 8 bits is a byte. Does anybody know what a 4-bit value is? It's called a nibble. A nibble. Did you? You really need to make sure you enunciate when you say that, though. Nibble, nibble. That's something you'll learn in the 325 class as well. So we'll call this guy nibble to hextet. We're using the official words here. So this guy will take in a string nibble, which is a 4-bit value, and it's going to give me the hextet version of that. All right, so now I can go through and I can basically do the same thing I did before for writing a binary. I can do binary to hexadecimal, but really I'm doing binary to decimal and then just converting it to the hextet as I go. So I can do that same lookup where I have string map is equal to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then A, B, C, D, E, F. And then I'll have an int place, starts off at 1. And then I'll have my string answer, starts off as the empty string. So int I is equal to 0, I is less than, I'm sorry, not 0, it's nibble dot length minus 1. I is greater than or equal to 0, I minus minus. So we're going to start at the end of the nibble, work towards the front, taking each value and turning it into a decimal value, right? So we're going to have an int sum starts off at 0. And then what we'll go ahead and do is we're going to say if nibble.charat I is equal to a 1, then what do? I go ahead and say sum plus equals place. Regardless, place times equals 2. Now, I could have also written this to where I effectively hard code the 16 potential values of 4 bits, right? And then just say, which string does this guy match? Because this is the code we already wrote, right? So let's look at an alternative to this and decide whether it's worth it. This will accomplish it. This is code we actually already wrote right down here. That's our binary to decimal. We already got that guy. So now what if I did something like this? What if I said, I'm going to create a collection of all of those binary values. So I'm going to create a string array called nibbles. All right, and this guy is going to have in it 0, 0, 0, 0. I'm going to steal this as my placeholder. 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, 0, 1, 0, 0, 0, 1, 0, 1, 0, 1, 1, 0, 0, 1, 1, 1, 1, 0, 0, 0, 1, 0, 0, 1, 1, 0, 1, 0, I'm going to kick this down a line. One, zero, one, one. One, one, zero, zero. 1101, 1110, and 1111. So there is a collection of my 15 nibbles which map to hextets, right? So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. So we'll have our string map is equal to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. And then what we're going to do is we're going to write a loop that's going to go through this array of nibbles, asking, does the nibble we're looking at match one of these? We know it will be one of them, right? We're guaranteed that it will be one of them. So we'll say for int I, actually we can do a for each loop for this. So we'll say string n in, actually I need to get the position. So we're going to say for int I. For int I is equal to 0, I is less than nibbles.length, I plus plus. So we're going to go through every value in the array called nibbles. And we're going to say if nibbles at bucket I, the current nibble I'm looking at, if that guy is, now we might get, we might feel like we should say if it's equal to the nibble we're looking at. What operator is this guy? What's that operator called? Equivalence operator. When does it return true? Like if I say 5 equals 7, is that true or false? False. So it returns true when both values are the same. Okay? Not that their contents are the same, but they are the same value. So in this particular instance, have I talked about using these for strings before? Okay. So let me kind of pause this for a second. I'm just going to return an empty string down here so it won't scream at me. And we're going to, well, all that up there is fine. I'm going to create some strings. I'm going to say string s is equal to hello. String s2 is equal to hello. String s3 is equal to new string hello. System.out.println s equal s equal s2 s equal s3 s2 equal s3. Now, as a human, we look at this and say, oh, s equal s2. Yeah, hello is equal to hello. That should be true. We expect this to be true. S equal s3. S is hello, s3 is hello. We expect that to be true. It's not going to be. It's going to be false. S2 equal to S3. S2 is hello, S3 is hello. We expect that to be true, but it's also false. So there's our true, false, false. The question is why is this false? When I write hello like this guy would be called the string literal that is hello. And what Java is going to do is it's going to look in its what's called literal space in its memory and say, do I already have a string literal that's equal to hello? If I do not, I'll go ahead and create one and put it into memory. Now, strings are object types, even though they often behave like integer, like primitive types. Object types are passed by reference, passed by address. So S actually holds a pointer which points to a place in memory where that string lives. All right, so for S will hold the original, in this case, it'll hold the original address where the string literal hello is stored. Now when I go to create S2, which is also the value hello, it's also the string literal hello. Java will notice, oh, I already have that guy. I'm not going to waste extra memory by creating it again. I'll just make S2 point to the same place that S points to. Both of those variables hold the same memory address. Make sense? That's why S equals S2. When a human looks at this, they say, oh, hello is equal to hello, because we're smart. We're looking at the contents. We mean to look at the contents. But the reality is that using the equivalence operator here is not resolving that memory address. It's saying, is this memory address the same as this memory address? And in that case, they are. Now this third variable I created though, S3, equals new string hello. I'm purposely using the strings constructor to construct for me a brand new string. The new keyword is our real estate agent. This guy goes and gets us new memory. So now I'm bypassing Java's default literal space rules. And I'm saying, I want you to make me a new string whose contents are hello. But this is new memory. Don't look for this in literal space. So S3 will have a different memory address, a brand new memory address associated with the string literal hello. So now when we say, is S's memory address the same thing as S3's memory address? The answer is no. That's why it's false. Yes, they both have the same string contents, but using the equivalence operator, we're not going to resolve the address here. We're just going to get the value of the variables, which are the addresses. Is this address the same as this address? Not is the thing at this address the same as the thing at this address. Make sense? So that's why this guy is false. Similarly, that's why this guy is false. Now, the way we have it written right now, it will end up working. And this is why I wanted to use this as an example. I kind of recall that I did cover this. Is this the first time you're hearing this? Okay. I promise I've covered it at some point in the last 20 years. At some point, it's happened. All right. Now, it will actually work in this case, which is why this is a little bit dangerous. Because as good programmers, we want to police ourselves, even if we sometimes can get away with some poorly written code. In this case, I'm using the double equal sign to compare this string to this string. If everything was built using literals like this, and I never use the new keyword, it'll happen to work out that the memory address of 0000 will match up to the nibble 0000, yeah, if they were both created as string literals without the new keyword. I will be comparing their memory addresses, not their contents. I'll just happen to get away with it this time because of the way I may have created them. But we can't rely on that because this is a function. This function says anybody can send me a 4-bit string. This does not say how they had to create that string, right? So I'm kind of playing with fire if I'm saying, hey, I'm going to check memory addresses here. So what we really should do is use the strings, because this guy here, nibbles at bucket I, boils down to a string. This string has a equals method that I can then use to compare to another string. The equals method says, does this string contain the same sequence of characters as this string? Make sense? So that's asking the question we thought we were asking before. Do these two strings have the same chars in them? Where in Python, the double equal sign, when applied to strings, does do contents comparison. So this is another example where Java has a nuanced difference from Python. In Python, I can use the double equal sign for comparing strings because Python looks at both sides, says, oh, these are strings. I think I know what you mean. I'm going to compare the contents. Java is like, look, this is an object. It's passed by address. You're using the equivalence operator. The equivalence operator is the primitive equivalence operator that compares two primitive types to each other. The primitive type I'm dealing with here is a memory address. It's a pointer. Primitive type I'm dealing with here is a memory address. It's a pointer. Are these two pointers the same pointer? The same memory address. All right. So I would call Java's implementation of this better. And also more correct across all languages. Python's implementation is more convenient. When you're learning programming, convenience, I think, is sometimes our worst enemy. Because sometimes we get away with something and now we think we understand it, but really we don't. It just worked. And that's sometimes dangerous, right? So I'd rather a language not do too much for you. Once we get into writing our own objects here in Java, I'm going to be showing you some examples from Objective-C. Because one of the things that Java does, which is nice and convenient, is it does not make you, one of the goals of modern languages is to reduce the amount of syntax you have to write. So let's say that when you're creating an object, you always had to write the same 3 lines. Every single time. The first 2 lines of your object and the last line of it are always, 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 always the same. Might it make sense for a newer language to say, okay, well, if these are always the same, I'll just not make you write this and not make you write this. That's great. It's convenient. But then all of a sudden, things magically have occurred and you weren't the one who had anything to do with it. It's good when we can recognize that convenience and be thankful that they've saved us writing those 3 lines of code. It's not so good when we're trying to learn the underpinnings of these languages and not realizing what the language is saving us. That makes sense? You know, so if you drive, I know it only goes back so far, but you know, your cars today have power steering. Well, people who grew up a long time ago, before cars had power steering, appreciate power steering because your cars used to be a lot harder to turn. You know, you have to really wrench the wheel a little bit to turn the wheel. Now you can turn it with your finger, right? So we can, now, most of you can use your imagination, right? And say, yeah, I can imagine that wouldn't be all that fun to not have power steering. Go back even farther. You know, what happens? You get in your car, you just turn the key. If your car even has a key anymore, right? Mine just has a push button. My keys are in my pocket. I never have to take them out. You know, but you get in the car, you just turn your key, it's on. Well, early days, you used to have to get out and crank the engine, just like it's starting a lawnmower. Wouldn't that suck during the winter? Okay. So if you ever had to do that, you could really, really, really appreciate the automatic, especially with fuel injection now. You know, you don't have to like prime your engine or anything. You know, I had an older boat before. And, you know, you got to get in the back with the pump and there's like a little squeeze thing. You got to squeeze it until it's, you know, you've gotten your fuel injected into the engine, so there's something to explode when you start putting sparks, right? Well, wouldn't that suck if you had to do that with your car? So there's some things we can use our imagination and say, yeah, I kind of appreciate we don't have to do that. But a modern day driver, when you learn how to drive in modern technology vehicles, you might say, you know what? I didn't know that's how it used to work. Now you can connect the dots when I mentioned it. But ignorance is bliss type thing. But since we're going to be professional software developers, we really can't afford to be ignorant of these things. We want to understand what's actually happening under the hood. And then we can appreciate the convenience of things auto-indenting for us, and, you know, being able to just hit the play button to make the thing run instead of having to compile it and then run it. These are all niceties that make our lives easier, but they're also hiding some stuff from us. Okay, so we're going to compare this nibble. We're going to say, is this nibble here, does it contain the same stuff as the nibble I'm currently looking at from my collection of nibbles? If it does, I know I'm currently at bucket I, whatever I is. So the first time through I said, is bucket 0 equal to nibble? Is bucket 1 equal to nibble? So on and so forth. If I find a match, I want to return map.char at I. Now, map.char at I will give me a character. I've advertised I want to return a string. So if I'm at bucket 0, it'll give me a 0. If I'm at bucket 1, it'll give me a 1. If I'm at bucket 10, it'll give me an A. Okay, so this will do that conversion for me from the 4-bit nibble to the equivalent hextet. If I have a char here and I want that char to become a string, what do? How do I make a char a string? Same way as we make an int a string. Remember, Java is a string-based language, so we have nice conveniences. How do I make a primitive type a string? Concatenate it onto the empty string. So this is a string that has nothing in it, and I'm going to concatenate onto that whatever this char is. And now I have the string version of whatever that char is. That make sense? Now down here, I can just say return -1 or something. That means I didn't find a match, but we know that all nibbles are accounted for in here. So as human beings, we happen to know that we will always eventually get inside this if statement. So I'll actually never reach this line here. But if I don't have this line here, Java's not going to be happy. Java's saying, hey, you told me you were going to return a string. Why didn't you return a string? This is different than Python. Python being a loosely typed language, we did not have to advertise what kind of values our functions may or may not return. We could just do whatever we wanted, right? You could have a function return a string, also a Boolean, if you wanted to have it return false otherwise. In this case, we've had to tell Java, I will give you a string as a result of this. Java's like, okay, now as human beings, because of the nature of the problem we're solving here, we happen to know that we will always hit this return statement just because of the nature of the problem we're solving. With that being said, this for loop is a pre-check loop, which means we ask this Boolean expression before we get into the body of this loop. So there's really no guarantee from Java's perspective that this loop executes even once. Similarly, here's another question. There's no guarantee from Java's perspective that this Boolean expression will ever be true. So from Java's perspective, there is not a guarantee that we will definitely ever get to this line. Yet Java says, you told me you will definitely return a string. Or based on the code we have written here, Java can't confirm that. That's why I had an extra return statement outside of this loop. Java's convinced that, look, no matter what happens in here, if you're still kicking, you'll return a string right there. That make sense? So a consequence of Java being a strongly typed language is that since we've advertised we're going to return a type, we are now enforced to return that type. I prefer that. I prefer strongly typed languages from a learning programming perspective because it does police us, right? Where in Python, sometimes you forgot to return anything, you would just get that random none as your answer when you went to print it out or something like that. It's like, well, why is it none? Well, you didn't give me an answer. You never returned the answer. So Python will let you get away with it. Java won't even let you run the program. Something like that. All right, so this guy right here will take any nibble and spit out the hextet equivalent as a string. That make sense? Okay, so now all we need to do is walk through our padded bin 4 bits at a time, feeding those bits to our nibble to hextet and getting our final answer. That make sense? So we know bin is properly padded here. So I'm going to say for int I is equal to 0, I is less than bin.length. I plus equals 4. I'll take hops. I'll go from bucket 0 to bucket 4 because I want bucket 0, 1, 2, and 3. And now I'm going to have my answer. So answer will equal the empty string. And what I'll say is I'll say answer plus equals. Oh, actually, we'll write it out. Answer is equal to, because we're going to tack our, actually, we're going to do it in order. So answer is equal to answer concatenated with nibble to hextet. And the nibble we want to give it is the string containing bin.char at I concatenated with I plus 1, I plus 2, I plus 3. So this will build a string out of the next 4 chars in that binary. So it builds a nibble. And then notice I'm jumping by 4. Also notice that I'm guaranteed that bin currently has a number of characters at the power of 4 in it. So since it's going to jump by 4, we're missing our first one. I is 0, so we have our bin. This is bin.length. One, 2, 3, 4. 4 is going to be the next one. the nibble to hextet, empty string plus this character. That should be 4 bits. I'm going to print out answer as we're going through here. See where our issue is. So why are we missing the 1? My padding not doing what I thought it should be doing? Oh, it's not. Pad 0 for hex. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So 18 mod 4 is 4 remainder 2. Zeros to add is 2. Why am I getting a 5? So the second thing I'm printing out the, no, first thing I'm printing out is the 1. I know my length is 18. 18 divided by 4 is 4 remainder 2, right? 18 divided by 4 is 4. 4 times 18 is 16, so that has a remainder of 2. Okay. So zeros to add here should be a 2. I'm printing it out here, and I'm getting a 1. Why? 18 mod 4 is 2. Okay, hold on. Why is it 17 there? One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. It is 17. Oh, hold on. We have to do 4 minus that. So zeros to add is 4 minus the leftover of that. I need to add 3 to this guy. Yeah, so there's our answer. So our error was in our pad 0 for hex. I was getting how many numbers short we are. And what I needed to know, well, no, I was getting how many extra bits do I have. So in order to get the number of zeros, I need to take 4 minus the number of extra to give me the number of zeros I had to pad to make it a multiple of 4. So there is our answer when you break it down into nibbles, 1557F. So it should have been the same answer we got before. So our bug there was the padding function. Because we do need to make sure that bin is a multiple of 4. These being 4-bit chunks. That's why we add, in this case, we would have added 3 extra zeros on the front to make that guy have a length of 20 instead of a length of 17. 17 mod 4 is 1, 4 minus 1 is 3. I need 3 extra zeros padded on. All right, so we have our initial number. We pad it to make sure it has a number of bits that's divisible by 4. I'll take out my extra print statements here. Actually, I'll show you something else here in a second as well. Instead of doing print statements, I'll show you a better way of looking at this. All right, so pad it, then go through and grab 4 bits at a time, passing it into our nibble to hexdet converter that we wrote, and that'll give us our individual hextet. So it gave us a 1 the first time, a 5 the second time, a 5 the third time, a 7, and then an F. So that's another version of converting between, I'll just take these extra functions out so you have just this version. Okay, so another version of converting from binary to hexadecimal fairly directly. I know this seemed like a lot of work, but you see it's kind of shorter code. And at the computer level, we actually do bit shifts and bitwise ands and ors to accomplish this. So we don't actually need to grab it 4 bits at a time. We can take 4-bit bytes out of it to get to the values that we're interested in. And you'll see that in the 325 class. All right, so I'll go ahead and push this. So we'll call this guy direct convert from bin to hex. And the punchline there is that's why hexadecimal is a value system used in computing, because you can easily go from binary directly to hexadecimal. You don't have to go to human numbers first. Okay, so questions about any of that stuff? All right, so let's look at functions. This is that string comparison thing. So within the slides, you can look at. All right, we want to start writing classes. Let me just see what the next all right, so we want to look at, we're at 1250, right? Okay, fine. We got time. So we're going to look at creating some classes here. So here's some examples for classes, but I'm going to show you a live example. So this is something similar to what we did in Python last semester. We created our own objects, right? So we're going to see the Java version of doing this. So I'm going to create another file. we've been creating our main class driver, the one that has main in it, because all programs begin and end with main. We've been creating that inside of the driver.java file, which is a class, but it happens to be the class that drives our program. That's why I keep calling it driver. So what I'm going to do here is I'm going to create another class. And I'll mimic the thing we have in the notes. Actually, no, I'll do something a little different. So I'm going to create a class called a person. All right, I'm going to have a class called person. And what we're going to do in here, yeah, I'm going to make them private to begin with anyways. So we're going to say that a person, remember that classes have collections of fields, constructors, and methods. So that's a 200 concept. So we're going to say a person has a first name, a last name, and an age. Right? I'm going to make all of these private for right now. We'll talk about the security levels of these next time, but this will make sense once we get into it. I just want to give you a functioning example that you can use to do your homework. So we're going to have a private string f name, a private string l name, and a private int age. So again, we have a strongly typed language. We have to define the fields we're going to use and the types that they're going to be. Or in Python, when we had our constructor, we just invented the self.fname is equal to whatever was passed in for fname, self.lname, so on and so forth. Okay? Java requires us to pre-create these with the types that we expect. All right, so now we're going to have our constructor. If you remember, in Python, our constructors were always called underscore, underscore, init. So in Python, we probably would have had something like fname, lname, and age is what we would have been taking in for our constructor. Actually, here, I'm going to, just so you have some live stuff. And then inside of there, we would have said something like self.fname is equal to fname, self.lname is equal to lname, and self.age is equal to age. That would have been our constructor in Python. We would call it def that. Kind of remember that? All right. So the equivalent in Java, we're going to have something that's of type public, and we'll talk about security stuff next time. So for now, just make it public. And the constructor has to have the identical name to the class. That's true in Java and C# and C++. So we're going to have public person, but notice it does not have a return type. So even though constructors look like functions, they don't return a value. Therefore, we don't give them, we don't have to define void or whatever value it would otherwise return. I'll point that out why here in a minute. So this guy's going to take in a string fname, a string lname, and an int age. And we'll say this dot fname is equal to fname. This dot lname is equal to lname. This dot age is equal to age. So in Java, instead of saying self dot, we say this dot. So self was how an object referred to itself from within itself. In Java and C++ and C#, this is how an object refers to itself from within itself. We're talking about this object. Okay? So these are synonyms. Not a new concept, just instead of self, it's the word this. I'll just write a little method in here that does something. Teach a person how to display themselves. something like that. So now I can create people with ages, first names, last names, and ages, and then I can ask those people to display themselves. So I'll go into driver here. I'll go ahead and create a person, P is equal to a new person, Mike Littman, just turned 21, and we'll say P dot we are in the default package. Public class person, public person. Why can it not find my class? Oh, because I put it in a different project. So let me just open up person here real quick. I'm just going to copy all this, and I will close that project and go into this one, and I'll create a new class real quick called person. Save that, and make sure I have the correct driver open. Okay, there, he's happy now. I put my class in last week's project, or on Tuesday's project. I just did that so when you make that mistake, you'll know not to do that again. Yeah, so I do those things on purpose as an educational opportunity. Okay, so I created an instance of person. So my variable is of type person. Its variable name is P. It's going to be a new person. And if we want to see the equivalent in Python, this would have been P is equal to person, Mike. Like that. That's how we would have written this in Python. The equivalent line in Python is this in Java. So my type is person, variable name is P, equals a new person. So I'm getting a new memory address, and these are the three parameters coming into it. The person constructor, we see over here, takes in three parameters. It sets the three things internally equal to that. And then I'm telling that person to display themselves. Similarly, I can create a second person, and this is Mr. Gonzalez. I think he's 9 now. He's 9. And then we would say P2 dot display, and there's two different objects. Now, one thing that we can't do that you used to be able to do in Python is I can't say something like system.out.println, and we could have prevented this in Python, but we didn't. I can't say p.fname, for instance, because I made my first name private. We'll talk about that in more details next time, but just the workaround for that for now is I can give myself a getter. I could say public string get fname and just say return this .fname. So now I've given myself public access to one of the private members. You can, but I'm going to say that's never a good idea. And we're going to talk about it next time, but it will work, but it's bad programming practice. And I'll explain that in more detail next time. But for now, this gives you enough to do your homework. All right, questions, comments, concerns, bribes. So homework assignment for next class. Create a Java class called Bible Book that maintains fields for the book name, number of chapters in the book, and a short summary of the book's contents. Your class should also just support displaying a book object in a reasonable way. Test your class by creating 3 instances. Something pretty similar to what I just did, but for a different type of object than a person. All right, questions? Go ahead. Sure. And I'll put this code up. I'm going to push it to the solution for the homework. Yeah, but here it is. If you need to just look at it. But it'll be my third commit, third push on the. Yeah, then you can just click on history and see the thing for. All right, I will see everybody on, what day of the week is it? Thursday. I'll see you all on Tuesday.
Just a quick question. So,
I'm listening.
So in Java, do you have the same class on the same?
You can put them on the same file.
So you're just doing it to make it easier on yourself.
Typically, the way I'm doing it is the way you would do it. Yeah. Python, you could also have it in separate files, but because we're kind of just getting started with programming, yeah, this is the more appropriate way of writing it.
What's the difference between INT versus
integer with a capital I is a class. It's a class type. So it allows you to do extra things to integers. Int is the primitive type int. It can only hold a value. Integer is the object type.
Is there a different size of thing?
No, I mean, we're going to look at like integer.parseInt, and int can't do anything else other than hold a value. The integer class exists to do things to integers.
It's better to just type out all these classes, or
well, no, I mean, because we already have a way of holding integers called int.
So we should just type
the integer, well, I mean, they are different animals.
Okay.
One is a way of holding an int. The other one is a tool for operating on ints.
Okay, so depending on what we're going to do with it, we should either make it an int or make it an integer.
You would, for right now, you would never create an instance of integer. You would look at integer as a tool for doing things to ints. Because ints can't do them themselves. I understand. I'm saying they're not the same. Integer, you will never create an integer variable right now. There are situations where you might, but for right now, you would never do that. If you need to hold the number, it's always an int. The integer class is like a hammer for doing stuff to ints. Does that make sense?
Yeah, I was just typing it out as an integer, so I was trying to figure out if that was like a problem or
Yeah,
anything.
you're not working with the same animal. By typing it out as an integer, you are creating an object of type integer. It will work, but that's not what you'll see as an industry standard. Ints are our primitive types in Java. Integer is an object type that allows us to operate on int primitives.
What's like, you give like an example of what you would do?
Integer.parseInt
is
something that produces integers from a string.
Okay, so when you're like creating a variable, you never want to like do integer. You don't have an int.
For right now. I mean, that's a slight lie because I could give you some examples, but
could you take like an int and then have it equal to integer.parseInt or something else?
Well, sure, because I mean, if you had the integer 7, and then you said integer equal integer.parseInt double quote 7 double quote, that would be a true statement. The parsed version of the string 7 will give you the number 7, which you can then compare to an int.
Okay, I'm just trying to like better understand. Like,
Right. And that's what I'm trying to say is really look at the integer class as a tool. Think of it as like a hammer that lets you do things to
so
ints.
as of right now,
don't think of it as a variable type. Don't think of it as something
so
for holding a value.
Variables, just create variables.
Correct.
And then
use it to operate on integers.
When you're trying to like change that part of the person
Well, right. And the reason for that is because ints, as well as chars and floats and doubles, they can't do things to themselves. All they can do is hold a value. That's their limit. They have a limited capacity. And it's just to hold a value, which is why the integer class exists. Because sometimes we do want to do stuff to integers. And they can't do it themselves, so we need this extra hammer to be able to do it. What's up?
Yeah, I wanted to finish up the.
Oh, so you don't need me, you want to see this. All right, hold on, give me 1 second so I can at least get the video converting.